Okay, here's a video for lesson 36, solving radical equations. This is our introduction to solving radical equations. The next step will be a little bit more involved. But for these, our steps are just to isolate the radical through standard equation solving algebra. So we get the radical, like this, by itself. Then we are going to square both sides to get rid of the square root. We'll solve for the variable, and then we'll check our solutions in the original equation. If it doesn't work, we'll call that an extraneous solution. That's this word, extraneous. And that means that it doesn't actually work. It's not actually a solution, so we'll cross that out. Now I'll go through a couple examples with you. These should be pretty quick. We're going to do exactly this. We're going to isolate, we're going to square both sides, and then we're going to solve for the variable. And we'll check it back in, but I'm going to do that real quickly. So, for an example like question 2. Here's the radical. The radical term is this term. In order to isolate it, I need to get rid of this 9. So in order to get rid of the 9, I'm going to divide both sides by 9. Those cross out. I get radical p plus 7 is equal to 90 divided by 9, which is 10. I'm going to square both sides because it's isolated now. Square and the square root cancel. I wanted to square on the left to get rid of the square root, but I had to square on the right as well in order to balance out the equation. So p plus 7 equals 10 squared, which is 100. And I'll minus 7 minus 7. P equals 93. Now if I plug back in here, 93 plus 7 is 100. So I'm just doing the left-hand side, seeing if it's equal to 90. So let's see, the square root of 100. 9 square root of 100 is 10, so 9 times 10 is 90. That's what we started with. That checks out. That was supposed to be a check mark, not a W. I want to, geez. Okay. A question like question 7. It doesn't matter which radical you want to look at. Let's say the left one. It's already isolated. There's nothing here except for the radical. There's nothing on the outside. So for a question like number 7, if I want to square the left, I also have to square the right. The square and the square root cancel. Oh, and look, the same thing happens on the right. This actually becomes a very easy equation. Negative 2 minus n equals 3n plus 10. I want to get the variable by itself, so let's say plus n. I get negative 2 equals 4n plus 10. Forgot the 1. I want to get n by itself, so let me get this 10 out of here. Minus 10 minus 10. Negative 12 is equal to 4n. And I'll divide both sides by 4 to get the n by itself. Negative 12 divided by 4 is negative 3. Now if I plug this back in here, negative 3 for here, this left side becomes the square root of 1. And this right hand side, if I plug the negative 3 in here, this becomes square root of 1. So they are equal. This does indeed work. The last one that I'll do, question 16. Now this is just based on a definition we did in class. We said that anything raised to the 1/2 power is the same thing as that thing underneath the square root. So I'm going to take these under the 1/2 power. I'm going to rewrite them underneath the square root. Now it's just like the question we just did. Square both sides. Squares and square roots cancel. I get r plus 3 equals 2r minus 4. I'm going to minus r, and I'm also going to plus 4 and plus 4. So I get 2r minus r is r. Put on the equal sign. 3 plus 4 is 7. And so that's my solution, r equals 7. If I plug that back into the original, up here, r plus 3 to the 1/2. Let's see what that's equal to. R plus 3 raised to the 1/2 power. 3.176, okay. The other one is 2r minus 4. Okay, so 2r, 7, minus 4 raised to the 1/2 power. And it's the same thing. So the left and the right side of the equation are equal when I plug in 7 for r. So this does work. Okay, and that's essentially all you need to know. Good luck. See you in class.